Hello out there and welcome to another video by the team here at BlenderTech.com. That's BlenderTech.com. Unity videos will soon have their own website. We currently use version 4.5.5 F1. We've now upgraded. Please like the video if it helps and subscribe for more videos on Unity 3D, Blender, and coding. The team tries to put out between 3 to 10 videos a day, and don't forget, create your way. So today is going to be an intro on physics in Unity. This will be a 3-part series. In part 1 of 3 of this video series on Unity physics, I'm going to give you an introduction to basic physics within Unity. You will learn about mesh colliders, rigid body physics, and more object creation and manipulation. Physics are exactly as it sounds. It allows us to have our objects have real-world properties so that they interact exactly how we want them to with other objects. Let's start up a new project. So go File, New Project, and then create a new project. So I already have my path here, but choose a path to keep everything organized. Call it something like Physics Part 1 of 3, just like I have, and then hit Create. You'll see the splash screen come up, and then we'll be ready to go. So again, I'm going to remind you about this splash screen that comes up quite often. Until you know how to use Unity well, I suggest you don't uncheck Show at Startup. The video tutorials are great, the Unity basics are great, Unity Answers is great, and the forums are always great if you have a question. And again, we'll get into the asset store in a video very soon. So close that off for now. Anyways, let's get started on our fresh new scene. So, let's start by recreating our cube. Remember how to do this? Click Game Object, Create Other, and then choose Cube. As you will see, it's created a cube right at our origin. Remember, the origin is 0, 0, 0 in your inspector window under the transform component and under position. So we're at 0 under X, 0 under Y, and 0 under Z. Let's move it up 4 units from the origin point. So we can do that by translating it manually by dragging the arrows, or we can do it by just typing 4 in the Y box. So now if we zoom out a little bit, we can see our cube is 4 units above the grid floor. Up above the transform window, in the inspector toolbar where it says cube, we can give it a name. Let's call it character 1 again. As you can see in the hierarchy window, it's changed to character 1, and so now we can select it there, or we can click on it in the scene view, and this cube is now called character 1 as we had before. Let's create 3 planes now, just like we would in Blender. We do this by going Game Object, Create Other, Plane. So as you can see, it's created a plane right on the origin point. This is exactly what we want. Leave this one at the default origin point of 0, 0, 0 and leave the scale exactly the same. Let's call this one Floor 1. Hit enter and it changes its name. Now let's create another plane. So go Game Object, Create Other, and Plane. And as you can see, it created a little bit off from where I would have liked it because I'm not quite lined up. But that's okay. Let's move it back to the origin by typing 0, 0, 0. And this one's going to be 1 unit down. So in Y, type -1. So there you go. It's now 1 unit below our top floor. Let's create a third plane. Game Object, Create Other, Plane. Again, it's created in a weird spot. Let's go 0, 0, 0 to move it back to the origin. And this one is going to be 3 units below. So -3. Or -2, I guess. So we have a plane at origin, 0. A plane 1 unit below -1, and a plane -3 units below in the y direction. But everything is all lined up in the x and z otherwise, and our cube is 3 units above. Don't forget, as I did, to rename your second floor floor 2 so that everything's organized, we know what we're working with. And the last one, name it floor 3. Unity uses NVIDIA's physics engine for its physics. This is the industry standard for real-world physics simulation and is used in most major video games. Let's begin playing with some physics. Select your cube either by clicking on it in the scene view or select it in the hierarchy, which I select you do because your scene view can get very cluttered very fast. And as you will see, our cube object, which we've called character 1, has a box collider component added and checked off. If it doesn't, you can always add it from add component, but by default it's going to have a box collider. Because it has a box collider component, that means it's able to collide with other objects that also have a box collider component. So that our cube doesn't fall through our floor, let's make sure all 3 floors have a collision component added and checked off as well. So floor 1, it has a mesh collider. Floor 2, it has a mesh collider. And floor 3, it has a mesh collider. So we're good to go. If you click play in your scene, however, you'll notice that your box just sits there and doesn't move. What's the problem here? Shouldn't it fall onto our first floor? Well, here's how we fix that. Let's uncheck play so we go back to scene view, and let's fix it. What we're going to do is we need to add a rigid body component to our cube. Let's add that now. To do this, make sure your cube, or in this case character 1, is selected, and then we're going to add our rigid body. To do this, from the main menu at the top of the window, click Component, Physics, and then Rigid Body. In the inspector window now, you will see that it has a rigid body component added, and you can adjust the values like mass, drag, angular drag, if it has gravity enabled or not, etc., etc. The default settings are fine for now though. If we now play our scene, you will see that the box is going to fall and hit the first floor. Let's try it out. There you go. It now has physics enabled. In this case, rigid body physics. By default it doesn't, but because we've added the rigid body component, it now falls by default. Let's do it one more time and watch our cube fall down onto the first floor. If it falls through the floor, make sure again that your floors have the mesh collider checked off, otherwise it'll fall right through them. Now let's select the first floor. Do that by clicking floor 1 in the hierarchy window. Again, you can do it from the scene view, but I suggest the hierarchy window. Select floor 1, and you see this checkbox beside its name? That enables or disables the object completely. As you can see, when we disable or when we uncheck the box, it's completely invisible, it's gone. It's still there, but you don't see it, and none of the components take effect. So let's see what happens now that floor 1 is unchecked. Let's hit play. Notice our cube falls onto the second floor? That's because our floor 1 was unchecked completely. Let's go back to scene view. Select floor 2, and we're going to change it up a little. Instead of unchecking the main box beside its name, uncheck the box next to Mesh Collider. As you can see, we can still see the object. However, we've unchecked the Mesh Collider. So what do you think should happen? Let's find out. Hit play. As you can see, it fell right through our second floor and onto our third floor. Because of our camera's view, you can't see it, but it is resting on our third floor and it fell right through the second floor. So the second floor is still there, we can still see it, but it doesn't have mesh collider properties, so rigid body objects are not going to collide with it. This would be used in your game for just creating objects that don't need the mesh collider component. So by unchecking the mesh collider, the rest of the components stay active. So transform is still active, we can still move it around. The mesh renderer is still active, it's still cast shadows and receive shadows, and we can add materials and such, and so on and so forth. So our cube is now resting on the final floor. Let's go back to scene view one last time. If we select our third floor and either uncheck the box beside its name, or if we uncheck mesh collider and hit play, now our box is just going to fall continuously. If we select character 1, you will see its position is constantly falling, and it will fall forever and ever and ever until the computer runs out of memory space. And this would probably be some sort of, I would assume maybe a float number or something, so it's going to fall for a long time, and that number will get very low. So that's what happens if you uncheck the mesh collision component. So that's just the basic introduction to physics. In the video's second and next part, we will be exploring in more detail some more about physics within Unity. The third and last part will be about creating and changing our own physics materials that can be used over and over on different objects to make them act like ice, glue, a bouncy ball, and whatever else you want. So that'll be a bit more fun. But this was just an introduction to basic physics in Unity. Thanks for watching this video from the team here at BlenderTech.com. Again, that's BlenderTech.com. If you enjoyed this video and it helped, please like it and don't forget to subscribe for more Unity 3D, Blender, and coding and programming tutorial videos. We try to add between 3 to 10 a day. If for some reason you dislike this video, don't just leave. Please add a comment that tells us what we can improve on so that each video gets better and better. For private concerns, we can be emailed at info@blendertech.com. We also take input as to what we should add more of and tutorial requests. See you next time, and remember, create your way.